Okay, today we move on to 6.1 Graphing Systems of Equations, Day 1. These discussions go a lot better when there's more than one person. What do you think a system of equations is? Well, if it's a system of equations, it's got to have more than one. What is a solution to a system of equations? It's a point that works in all the equations. So if you look at these two equations here, you'll notice that the point 2, 1 works in both of them. So if we plug a 2 in for x, it gives you 2 times 2 minus 3. Plug the 1 in for y. And 2 times 2 is 4, minus 3 is 1. So you get 1 equals 1. That's what makes it work. If we plug 2 and 1 in here, you get 1 equals negative 3 times 2 plus 7. Negative 3 times 2 is negative 6 plus 7 gives you 1. So you get 1 equals 1 again. That's what makes it work in both equations, is that we ended up with 1 equals 1 when we plug the point in. So what would that look like if we were looking at a graph? Well, if we graph these two equations, and we're looking for a point that's on both of them, it would have to be, no, this is not, obviously not accurate, but it would have to look like this if it's on both of them, or works for both of them. It would have to be the point where they both are at. That's called a solution to a system of equations, and that's what we're going to work on today. So let's think of how many ways two lines can intersect. So they could have one intersection, like we just looked at, and that would be like that. And that would mean that we have one solution. I would write this little table down just so that it's going to help you in the long run. Put it down. Another way that the lines could be, and I think it's easier to picture them first, and then you can tell how many solutions there are. I just drew two lines, a red and a blue one. And how many solutions would there be? Well, there's one here, and there's one here, and here. Technically, we could go in between those points and then go there. And so there are an infinite number of intersections because those two lines are the same, which means there's an infinite number of solutions. So we have lines crossing, two lines that are exactly the same. The other one is two parallel lines. Now these are going to run side by side forever and ever. If they're running side by side, how often do they intersect? Well, those are never going to intersect. So they're never going to have any solutions. Zero or no solution. Okay, so that's a good start to what we need to do for today. Today's objective will be able to find a solution to a system of equations by graphing. So, you see how the graphing is so important to us. I emphasized it when we first learned graphing for one equation. I emphasized it again at the end of last chapter when we did the linear inequalities. I'm going to emphasize it again. You should know how to graph equations of lines by now. Okay, example 1. Graph each line to find the solution. So the first one is y equals 2x minus 3. For those of you who don't remember how to graph still, we start. Step 1, start with y-intercept. And then because I'm a nice guy, I'm going to point out what the y-intercept is first. You're welcome. Okay, so that's -3, which means we go down 3 on the y-axis and make a dot. Step 2, follow the slope. M, which is rise over run. So you go up 2 and over 1. Why? Because every whole number divided by 1 is what gives you the whole number. So that's got to be a 1 in the bottom. So you go up 2, that's the rise, and the run is over 1. Up 2 over 1, up 2 over 1. You get the point. Now we're not worried about dotted or not dotted lines anymore for now. So we drew our first line. Now we have to do our second line. Now you'll notice that we have 2 different lines. I would start by doing 2 different colors if it helps you. You're going to go up 7. 1, 2, 3, 4, 5, 6, 7. Make a dot. Then go down 3 and write 1. Down 3 and write 1. Draw a line between those points. Now your intersection is going to be where those 2 lines intersect, where your solution is there. So you need to know how to do ordered pairs. You go over 2 and up 1, so it would be the solution 2, 1. Now it says, how do we know that our answer is correct? Because I know that your graphs are not going to be perfect. There could be squiggles in them. There could be issues. If your line is just a little squiggly, you could end up with it intersecting here. And then your answer would be 4 or 2.5, 2. And that's not the right answer, right? So check your solution. Plug it in. 1 equals, we just took the 1 and plugged it in for y in the top equation. 2 times, plug your x in, -3. 2 times 2 is 4, -3 is 1. We get 1 equals 1. And the second one, I'm glad I just now realized that we've already done this once. -3 times 2 plus 7 gives you 1. So it's 1 equals 1 again. So it checks out for both of them. All right, let's move on to example 2. Graph each line to find the solution. We start with our y-intercept by going down 3. You make a dot. You go up 4 over 1. Up 4 over 1. Draw your line. The next one is -3x plus 7, so you go up 7. Make your dot. And you go down 3 and over 1, down 3 and over 1. Draw your line. Now, how does this line look? It looks like they intersect right here at about 2.5 and 3. So, as you can tell, we're not always going to have a perfect answer. Let me think about this one here. Our x would be down 3 over 1. 7. See, this isn't even perfect enough for me to like it. I don't like this at all. Oh well, that's what it says, huh? So let's go ahead and plot it. Or plug your answer in. So we have 3 equals 4 times 2.5. Well, 4 times 2 is 8. 4 times a half is 2. So 8 plus 2 is 10. It gives you 10 minus 3. So you get 3 equals 7. No good. So we must have a problem here somewhere. So let's try the question again. Let's graph each line to find the solution. Start at negative 3. 1, 2, 3. Make a dot. Go up 4 over 1. Up 4 over 1. It's a little off. Not by much. This one we start at 7. So we go up to 7. 1, 2, 3, 4, 5, 6, 7. Make a dot. Then we go down 3 and write 1. Once again, a little off, but not by much. So, what's our problem here? Our problem is that even if we guess this all over again and we say, oh, well, it's intersecting here at 2.5 and 2, then even guessing again, still going to screw us up because 2.5 and 2.5 still probably isn't going to give us the right answer. What do you see with graphing to find the solution? It's never going to be exact. Therefore, graphing is not the best method to solve systems. Its whole purpose is to show us what a system and its solution looks like. So, in all cases, I'm going to want you to graph them, and then I'm going to want you to estimate. Now, I messed that all up, but estimate. You can say 2.5 and 2.5. That's not going to be right. For the ones that I give you, they're going to have clean answers, no decimals. So you should come up with clean answers. All right? We are going to learn far better ways to solve these systems in the future, so you know. Okay, example 3. Graph each line to find the solution. So we'll start with the first one. Go down 3, make a dot. Go up 2, write 1. Some of you may have noticed I like to put a lot of dots whenever I'm graphing systems of equations. The whole reason is it makes the lines much more, much more stable almost. There's not nearly as much problems with gaps or you not graphing it perfectly. It's a lot better if you have a lot more points. Okay, second one. Go up to 3, make a dot, then you go up to right 1. So the more dots, the better your line is going to look. Okay, where do these two lines intersect? This is one of our special cases. If you look at the slopes, and the slopes are the same, they don't intersect. So since these two have the same slope, it means that they're parallel. Since they're parallel, there are no solutions. It's a case to look out for. As soon as you see this 2 and 2, I still want you to graph them, but I want you to know that it's parallel. All right, example 4. Here we have it a little different. We have y equals 2x plus 1, and then we have 2y minus 4x equals 2. What's the problem with the second equation? It's not in slope-intercept form, so you have to get it into slope-intercept form, which means you got to get y by itself. So we're going to add 4x over to the other side. Gives you 2y equals 4x plus 2. Divide by 2. Those cancel. You get y equals 2x plus 1. What's the problem here? Nothing. It's in slope-intercept form. So let's graph our first line. It is 2x plus 1. You go up 1. You go up 2 and over 1. Up 2 over 1. Draw your line. And our second equation is 2x plus 1. So we go up 1, make a dot. Up 2 over 1. Hope you've all seen this at least by now. It's forming the same line. Whenever they form the same line, there's infinite solutions. And that's going to be your answer. Okay, let's do some U-tries. I want you to graph each line and estimate the solution. Obviously, you're going to want to pause the video while I do these. So you're going to do them on your own while I do them. Okay, number 1. Y equals 2x plus 3. Start by going up 3, make a dot, go up 2 and over 1. By the way, I have made an executive decision here. I'm going to start putting videos of your homework online the day after they're due. That way, once I grade, or once they're collected, I get them, I send them back to you, which, if you're not getting your homeworks back, start asking the teachers. I've been sorting them out by name, so there's a lot of work for me, but ask the teachers to get your homework back. That way, when you get them back, you can look on YouTube and watch the video for how to do your homework. Gives you a little extra incentive to get your homework correct, so you're doing well on the test, and it shows that you're willing to put in that extra work. Also, you can always email me and ask questions. I've responded to some of you Some of you have not liked my responses, but I've responded either way. Second equation, you go down 3 and right 1. After starting at 1, you go up 3 and left 1. Wow, right off the bat, we got an ugly one. It could be a description for most of you in the class. Just playing. Okay, when you graph it, it should look like this. And your point of intersection should be right there. We'll say negative 0.5. And 2.25. Looks good to me. Like I said, on your homework, I'm pretty sure none of them are bad like that. Okay, number 2. This one is not in perfect form yet. It's not in slope-intercept form. And so I have to put it in slope-intercept form first. So I have to add the 4x to the other side. It's going to give me y equals 4x plus 2. Also, on your homework tonight, they'll all already be in slope-intercept form for you. Tomorrow's homework, not going to be the case. Okay, so you go down 1, make a dot, go up 4, and right 1. Make a line through those points. Next one's 4x plus 2, so you start at 2. And you make a dot. You go up 4 and over 1. And run a line through those points. You should notice your slopes are the same. They were both 4. So this will be no solution. Okay, last one. Got to get y by itself first, so you divide by 3. Gives you y equals 4x plus 1. What we notice about these two equations, they're the same. So all we have to do is graph 4x plus 1. Up 1, then from there you go up 4 over 1. And draw your line. That's it. All right, you may start your homework lesson for the day, or your homework assignment for the day.